Hi everyone, my name is Nishchal Shrestha, and today I'll be presenting our tool Unravel, a Fluent Code Explorer for data wrangling. I want to begin by illustrating a very common style of programming in data science through an example analysis of the Palmer Penguins dataset using R. Here, a data scientist is using the RStudio IDE to analyze the Penguins dataset. They inspect the tabular data or data frame penguins on the console output. They then pipe the data to a function using the pipe operator percent greater than percent. Now they can apply operations to the data frame, such as selecting two columns, species and flipper length. They then chain together more functions to group the data frame by species and calculate the mean flipper length for each species. Now, this is a common programming design pattern called the fluent interface, where operations are chained together into a single expression to transform an object, which in our case is a data frame. Advocates of this fluent interface pattern suggest this style of programming improves readability, but what if there's a problem with the chain? Now, to investigate the missing values in the data frame, the data scientist has to engage in this cumbersome process of modifying the code by commenting out lines and re-executing the code on certain parts of the chain. Now, obviously, this is not a very fun experience, so there are a couple of problems with Fluent Code despite the benefits of legibility. First, because we are building up a chain of expressions, we lose the intermediate results and only have the final result to look at. Now, this makes it difficult to track changes made to the data at each step. And exploring the code is also a tedious process that requires messy code modifications and re-execution. So how can we help data scientists easily explore and understand Fluent code? Our answer to that is a tool called Unravel, which is a web application run within the RStudio IDE, and you can think of it as an exploration mode for the code. And the data scientist simply has to pipe their code into a function called Unravel, and this opens the application in the IDE. Now, one of the design goals was to help provide transparency about the data. So Unravel presents visual cues about the shape of the data frame according to rows and columns and the types of changes occurred at each step. Unravel provides function summaries as well, which are automatically generated by analyzing the changes between steps. And the summary describes the function's effect on the data frame and sometimes supplemental information to clarify subtle changes such as grouping the data frame according to columns. Unravel also visually highlights corresponding code and output elements to draw attention towards important changes. In contrast to traditional debuggers that force you to step through each line, Unravel enables data scientists to freely explore the code by clicking on arbitrary lines for further inspection. Here, a data scientist inspects the code and realizes that the flipper length column contained missing values. The data scientist now unravels new code that includes a drop NA function which fixes their problem. Unravel also enables simple structural edits to be applied on the code using toggle switches, which can be used to explore whether a function worked or not, or exploring the relationship between functions such as group by and summarize here. Drag and drop interactions can be used to reorder lines. For example, reordering the drop NA line before the select line reveals that there are other rows that contain missing values besides the flipper length column. We conducted a first use study of Unravel with 14 data scientists. This was a think aloud study where participants interacted with several code snippets covering prototypical wrangling operations. The visual cues were especially useful for providing transparency about the data. For example, P14 commented that it was very useful to have this at-a-glance information about the data shape and the type of change at times because it supports quickly checking if the data frames are correct. Now, interactive explorations on the code and data also enable checking assumptions. So, for example, P2 expressed that it's cool how it helps dispel goofy assumptions about what attribute persists versus not. It made me examine so many assumptions, especially grouping. Fluent interface is used in many different programming languages, so we could adapt this idea of Unravel to something like Python using the pandas library to wrangle and analyze data, for example. That is all for my talk. Thank you so much for listening. Please read our paper for more details on the implementation, the design goals of Unravel, and the rest of the results of our user study and discussion. Thank you.